Hello, my name is Matthew, and I have the privilege of being paid by Ericsson to make the world a better place through open source, and for that I am grateful. I wanted to show something really cool today, and it's a full end-to-end workflow. I have here my little IDE, and some of you may recognize the IPyNB, or Python Notebook, extension. We have a Jupyter workbook here. So, this is a wedding table organizer. Now, some of you may be getting married, maybe not. Well, I think that putting people at their tables is the job of a computer, not a person, and I think that this is a nice NP-complete problem we can look at. So before that, I made a little list of our guests. I'm going to open up the table CSV, the guest CSV. So you see, I put all 1,500 guests here because, we want a nice little marriage. And then I put the name, what their family unit is, because I didn't want to split families up too much. And then what their thoughts are on cheese, on ice cream, on cake, on pizza, and on programming in Rust. These are, of course, the highest, most contentious issues that you can ever face. Now, I made a nice little Jupyter notebook here, and I'm going to run it all now. So you see here we have our imports. Now you notice that there's the log scope command. I'm just going to scroll down. This should take about 35 seconds to run. Let's take a look at the code for the logger at the same time. Now this is a logger that I made. You have a log scope function wrapper, which basically puts a beginning and an end around everything. And then after that, you have a configure logger, which puts it in a separate trace. And something very interesting is that we're using UJSON instead of JSON to write. And because of that, it goes a lot faster. The code will be made available. Now, if you look at the performance here, it took 33 seconds. And you could see also that we have our logger, or our tracer, that wrote to test trace classic. So I installed the trace viewer, and I already have the test trace classic, so let's just open it up and see what's going on in there. We can look here at our flame chart. Find best table is being run, and you could see, for example, all your averages. But then let's go here, and that's your cost stack. Show latencies. Here's your stats. You could look at your Euclidean distance and see that it has a kind of okay standard deviation. This guy, average distance, has a crazy standard deviation, and the maximum is much larger than the average. Let's go look at the maximum here. Your average distance here is very large. So let's take a look at our code. We can go back to our notebook and see what average distance is. It's the sum of the Euclidean distances, or the Euclidean distance of the guest's opinions over the length. Honestly, as an optimization, I could have removed that division of length, but I didn't. Writing more divisions for nothing. That would not explain this performance. What we would need to do to figure it out is most probably get a operating system level trace and merge it with this to see what's going on. But all of this is possible within Trace Compass. You would make an experiment. I hope that this is a good way to start your journey into tracing from Jupyter Notebooks. I think that this is a great way to just understand what's going on, and also, of course, have your trace side by side with your program. Thank you, and have a wonderful day.